Welcome, welcome. Nice to see everybody here. Thanks for joining the webinar. We'll slowly start. So first of all, just to introduce the topic for today, it would be on the screen right now, and that's how to launch your hardware product without going totally broke. As we all know, hardware is pretty hard and it requires a lot of resources, and we mean a lot. And that's a few things that we'll cover today. Now, to just introduce myself, my name is Nicola. I'm the business development manager here at nAO.Design, a mechanical engineer by trade. So I'd like to take your attention away to our guest speaker today, Alex Fishkin. His camera will be off due to some Zoom technical issues, so please don't mind that. But Alex has very extensive knowledge in mass manufacturable devices. He has more than 13 years of experience in new product development teams of LG and Yoda and Philips. Alex, if you want to just say hi so people know your voice.
Hey, Nicola, and thanks a lot for having me today. So as you've mentioned, we're having some technical issues. So you'll be the face of this webinar today, and hope you can do some lip sync for me. So off to you.
Yeah, sure. I'll do some lip syncing. I'll try my best. So Alex is our Chief Product Officer, but also our head of R&D. Very, very extensive experience, and I'm once again grateful to have you here today to show us some insights into hardware development. Now, a lot of you might be asking, like, who are these guys? Why the hell are they talking to me? So we are nAO.Design. We've been on the market for more than 10 years now, and we are a design center, a multidisciplinary one. So we do hardware product development and we do product design. So pretty much everything from ideation to mass manufacturing is something that and challenges that we tackle. So far, I'd say one of the most important numbers in our industry are the two ones that you see on your screen. And that's that we design and manufactured more than 35 devices to date, and obviously have more current ones that we're working on. But then again, the number that's, I'd say, most important in this case is that, yes, you can design and develop products, but are they real products? Are they out on the market? So in these 10 years, we designed and developed, basically over 3 million units of our designs are out on the market. And if you compile pretty much all of our projects, what we've gathered from users is more than 4.6 stars across the board when it comes to user experience and the product, like overall user feedback from the users of devices. Now, what you're seeing on the screen are some of the projects that we worked on, and I'll just go briefly through them. So you'll see different IoT wearable devices, dash cameras, indoor air quality monitoring solutions, both for B2C and B2B markets. But then also you'll see like IoT smart home solutions, different types of smart home hubs, and so on. But this is not limited to our entire portfolio. Just to demonstrate that we work in different verticals, here's an entire line of personal computing devices that we recently did that are hitting the market pretty much all across the board soon. And that's all from the AIO to the mini PCs to a laptop, and then a tablet, plus a whole line of accessories that's coming as well. I always like to include this slide whenever I'm talking with somebody, because this is personally one of my favorite projects. It required a lot of extensive work, and it was in development for about 14 months. What's great about this product is that, you'll often see smart home hubs and speakers, so to say, hit the market, but they never kind of sound good, right? So the whole challenge here was to provide users with a completely different user experience. So not only did we work with Harman Kardon to make sure that the 360 degree, how they call it, the sound is like immaculate and it sounds amazing as a speaker. The whole challenge was obviously because of the slab of a display at the front, right? And then what also we included in this project is a lot of different ways to interact with the actual device. So then you had like facial recognition and gesture controls, but also like voice commands. So it ended up being this very interesting project where users could interact with it in many different ways. And that's why it's overall loved by the people that the end user, right? So on the screen, let's say put from the biggest to smallest are the most common requests we get as a design house or a design center for projects. So you'll see like POS kiosks, a lot of IoT. Obviously, it has been trendy for a long time, and we've been doing IoT since 2016, like really focused on it. So you see a lot of requests from customers coming for different wearable devices and even industrial IoT, like asset tracking and so on, predictive maintenance. So this just showcases one of the most like common requests that we get as a design company. Now, if there are any hockey fans, I would like to just introduce the whole topic of hardware is hard. Once again, resources are always limited, but it's important to keep in mind that you miss 100% of the shots that you don't take. And thank you, Wayne Gretzky, for putting this together. But either way, just don't get discouraged by a lot of work that needs to be done in order to execute a successful project. So I would like to give the word to Alex to pretty much keep on going with the presentation and give you guys the details about cost breakdowns and various challenges you'll face when developing hardware.
Well,
Alex,
thanks
take it away.
for the intro, Nicola. And yeah, so once again, today we will focus on the technical aspects of it. So we'll not speak much about the stuff like product market fit and other product related and marketing related activities. So we'll spend a separate webinar to tell more about how to position the product, how to plan the product, and how to do a research. So today we are trying to focus on avoiding those costly mistakes which you'll meet along the way when you are designing and developing a new product. So here's the brief hardware development life cycle. So I'm sure you are well aware of typical steps, which all starts with the idea and being followed by some research, proof of concept phase, which is basically a very singular prototype which performs only one function just to make sure that it works properly, that it's well met by the audience, and so on and so forth. Another step is optional, but we do encourage our customers to follow the patent. So to make sure that no one steals your idea in a short amount of time. Then normally, if we are talking about consumer project or consumer products, there would be a design language in place, which basically will make your product unique, first of all. And another advantage would be having a possibility to use the same design language on the new the projects which haven't been launched yet. So, and it allows you to have basically a roadmap of products which would have something in common. Then important steps would be basically design, engineering, and documenting, and then prototyping. So you can iterate between those steps as much as you can to make sure that you go for the next steps with the tried and tested concept. So next we go for the MVP, which stands for minimum viable prototype. So it's something that you can already present to, say, to the focus groups, to get the early feedback and to improve something until it's not too costly to introduce some changes. And then there would be an AVT, DVT, and PVT, which are basically the stages of the product development. So where you will have a certain amount of prototypes to be validated against different checklists and different aspects. So each of those would have their separate meaning, but we'll not step into much technical details for this webinar. So probably it's a separate topic for discussion. And then if we succeed with the PVT, and all the pre-requirements and prerequisites are met, so we go into mass production. Yep. And what is so special about hardware products? So simple answer would be that they usually combine a number of disciplines like the industrial design, mechanical design, electrical engineering, firmware and software development. And of course, the software development can be divided into front end, back end, and then mobile apps. So it's all about the complexity, which adds up with each and every layer, and basically the cost of error. So first of all, it grows incrementally, and also it affects other aspects. So for example, you can have the perfect ID, and then if your firmware is buggy, so the user experience is totally spoiled. And on the picture, you can see the typical Gantt chart. So this one is very high level. So without going deep in details for each of the phase, so there would be definitely a huge set of the subtasks. And but this one is a high level view. And by the number of items, you can see that sometimes it's overwhelming. And basically,
it's a true exercise of like task management and project management.
Yeah, so it gets pretty overwhelming, especially when we step into manufacturing aspects. So and when we are getting the first prototypes and trying to fix and trying to test all the aspects. But yeah, it's just the brief example of not the hardest project around. So that's why basically why the hardware products are so special, because they're complex. And basically one of the charts I wanted to show you, there would be probably 3 or 4 of them. So please bear with me. So we'll skip this boring part pretty soon. So at the beginning of every project, unless you are doing them on a regular basis, so there would be a very high decision uncertainty. So, and I love the saying by Donald Rumsfeld. Basically, he listed 3 types of the problems or of the issues. First of all, there are known knowns. So it's the things which we basically know. Then there are known unknowns. So the things which we know that we don't know. And then there are unknown unknowns. So the things which we have never met before, and we even don't know that we don't know it. So dealing with this high level of uncertainty in the new projects, so is usually dealing with those kinds of unknown unknowns. And that's why normally when someone is asking ourselves, so why do we recommend to basically to use our services? So we help to deal with this high level of uncertainty in order for your journey to look like a walk in the garden. So we basically take all the issues on our side and trying to address it based on our experience. And of course, another important thing is the ability to influence the project. So, and the decision period. So as we move along, so at the very beginning of project, so basically you have the full ability to influence the project. you're able to twist, you're able to make some drastic changes. So you're able to pivot sometimes. So, but as we move along, so basically this ability to influence the project features and other aspects would be very limited. So that's why all the important decisions we should try to make as early as it's possible. And then another chart, so basically it shows the efforts for development. So as we can see, by the middle of the project development life cycle, so we would have the maximum efforts. So, but as it's seen from this chart, so if we increase the planning of this project at the very beginning of it, so later on we would be able to reduce this kind of hump in the very middle of the project development life cycles. And we also can reduce this kind of unneeded and unexpected actions, as well as the errors. And it would result in a faster project time, basically, which is very important. And I will touch this aspect later on. And probably the last one in this part is the cost of mistakes and changes. So as we move along, basically the cost of changes, so be it time or money or the mix of it, so it keeps on increasing. So, and talking about, say, the major steps. So one of the major increases would happen after we launch the tooling, for example. Every tooling rework is pretty costly. So it can be from thousands to tens of thousands, and sometimes even hundreds of thousands for a very complicated project. Or that there might be cases when total retool is needed. So just do it again from the scratch. So we definitely want to avoid that. And then another huge increase would be when we step into the mass production, but even worse. So in case if we've already shipped the products to the end customer, and it turns out to be faulty, so there would be a huge spendings, first of all, associated with reverse logistics, so shipping products back to you. And then, of course, you would have to rework those products and provide a replacement for end customers. So be it a refund or product replacement. So that's definitely something you want to avoid. As for the rough estimates of those cost of mistakes, there are multiple methods of calculating the expected overhead. But in all of those methods, you can just see the best case and the worst case. So on the first stage, basically the cost will not be amplified. So if you perform some changes on the requirements and requirements analysis and feasibility studies phases, so basically it will not be a huge cost. So, but see, when we move to the next phases, it would be even not doubled, but 8 times. Or at the very end, so when we already produced and shipped the products, it might be from 30 times to 1,000 times. So, and basically it shows that the amount of unpredictable spendings can be huge, and it can ruin the otherwise nice ideas and otherwise nice companies. So that's why we would once again encourage you to plan, analyze, and to make changes as early as it's possible. Well, talking about the complexity of the hardware products. So what are the ways of reducing complexity other than planning early and analyzing early? So in our activities, we use a number of frameworks. Of course, we don't want to reinvent the wheel here, and we are trying to stick to some of the methods which are basically available on the market. So one of those basically is written by Daniel Elizalde, and basically he creates a framework which decomposes the product development into major chunks, such as hardware, firmware, communication, cloud, and apps. And then we've tuned it a little bit since we are focused on the design activities. We've added ID and MD design. So the purpose of it is to, first of all, to have it separated for them to be deeply analyzed and planned, and then to understand how each and every part affect the other part. So I really encourage you to take a look at this IoT framework by Daniel Elizalde. So later on, we will provide the link to this document.
Alex, I'm terribly sorry to interrupt you. I will just put it back to full screen, guys. So please bear with us. And also, if you hear some drilling noises, my neighbors suddenly decided to remodel their entire flat. So I apologize for that as well. Just give me a moment here, Alex. Okay, there we go.
Yep, so, and probably the ID and MD part, as well as the hardware development would be the major stack. So where you would spend majority of resources as well as the money.
Yeah, I would just want to add here that you've mentioned a lot of these solutions, and obviously this is like an entire breakdown of these 6 aspects of hardware development. So my question, for example, is will you like show us some examples a bit later on like what's the best decision making on like which one of these to tackle first? Like how do you deal with that?
Yeah, definitely. So we'll go through the major spendings. So, and we'll discuss on the way of optimizing those spendings. So yeah, talking about the where we spend money. So today, once again, we are not talking about getting money, unfortunately. So we are not yet there. So as I've mentioned, majority of efforts and of funds you will spend on the ID and MD and hardware. So it might include a number of components like the BOM, bill of material, then the licenses on platform, then the tooling, which is a hefty spending. So then there are some direct costs involved from ID and MD development. You have to have some design resources for that. So then there's a patenting, manufacturing, packaging, certification, and logistics. So same can be said about the firmware development. So basically there are basically the man hours you would have to spend for the firmware development. Then there's a number of licenses. And then there are certifications. So depending on where you plan to use the firmware components, so you would still have to keep some certifications in mind. As for the communication, so depending on the protocol of your choice, so there can be some data transmission costs. So in case if we are using some cellular networks like the GSM, LTE, or infrastructure costs. So in case if you plan to roll out low power wide area network, such as LoRa, so you might have to have the private deployment for the hotspots if you are not shooting at public networks. Then for the cloud, you might have the subscriber fees, subscription fees, and then support fees. For some operations, like there would be added CPU time cost. And then there might be some licensing for analytics, which is usually a separate part of the pricing strategy for the cloud providers. And again, there might be some third-party components and modules, which are normally can be paid as well. And for the apps, again, so there might be some developments, so be it a mobile apps or be it desktop apps. There might be some costs associated with third-party components and modules. And again, there's licenses. Yeah, as for the types of costs, so I won't list all of them. So there are several major types, like the fixed costs. So basically, the costs which will not increase with each of every piece you produce. Then there's some manufacturing costs, which normally would depend on how many pieces you've produced, because one of the typical manufacturing costs would be bill of material. So basically, the cost of all the components you use. Then there would be internal costs associated with your internal spendings in your company. Then there are financing costs. Then there are support costs and warranty costs. So which might sometimes run very unpredictable. And then there are some fulfillment costs. So those include logistics, and those include different taxes and duties.
Let's try to move away from this slide as soon as possible. It looks like a lot of cost.
Through that. Yeah, so here's a very rough breakdown of the typical costs, but you can see the major costs. Probably you would have the fair split between the internal costs versus BOM versus fixed costs. So, and then we also should keep logistics in mind, which can eat up pretty large space in your cost structure. So that's why it's important to plan ahead with regards to logistics and with regards to taxes and duties.
Well, speaking of planning and being timely, I see some cost of delay, and that can be a huge issue, right?
Correct. So, and whilst we are speaking about the costs, so you would normally have several types, high-level types, if you will. So one is the direct costs, so the ones we've previously discussed, and another ones are indirect costs, so which are also there. So among them is the cost of error, or COI, how they call it, and the cost of delay. So, and let us speak about those on the next slide. As for the cost of delay, so basically each delay, in addition to the cost of mistake, so the extra cost you have to pay for those mistakes or delays, basically they involve the time to sell, so-called, and of course you lose the actual sales, postponing your market entry. So, and it involves not only this time to sell, it involves the basically estimated peak sales, which is normally planned at some point of time after the product was introduced to market and gained some traction. So, and basically your customers, your potential customers, they will prefer to use some of devices by your component, by your alternatives, and that's why probably you may end up not realizing your full sales potential. Next slide, please. Yep, and just to give you a rough estimate of the fixed costs, first of all, there's a manufacturing partner, NRE. So in case if you are not developing device in-house, so you would have to have a partner for that, and they would charge what is called non-recurring engineering costs, which normally include development, setup, trial runs, and testing. And it's very difficult to give you a range because there's a number of dependencies here. So first of all, it depends on the complexity of device. Then it depends on the scale of your manufacturing partner. And then, of course, location matters. So because if you manufacture in China, that would be one cost. If you manufacture in US, that would be another cost, very much dependent on the labor costs. But again, in our projects, so which we've participated in which we've successfully launched, it ranges from 20K United States dollars to more than 1 million for the complex projects involving the heavy R&D resources and so on and so forth. Then you have to plan the resources for the EVT, DVT, and PVT builds. So normally, as a result of those runs, you would have a number of prototypes for verifications of the different aspects. But normally, you cannot sell those units to end customer. So after they are tested and tried, so basically you will just have them as a sweet memory about the early times of development. So basically, and the cost secured would be the BOM cost of device multiplied by its quantity. So, and for the quantity, normally we are talking about several hundred pieces during all of the steps of the project development. But again, in some cases, there's a requirement to have a larger amount. So, for example, when the company wants to give out some samples to the trial users, to the alpha customers, and so on and so forth. So it's purely depending on your needs. And then another large chunk of spendings, it would go to the injection molding, stamping, and other tools and fixtures. So basically, you would have them in case if you want to go into volumes, and if you want to have a nicely looking housing, but at the same time at a reasonable cost. So, and again, it purely depends on the size, physical size of your product, material being used, and it also involves the geometry, and again, your tooling partner matters, and the country of its location. So, but normally we are talking about the range from 10K USD for some small products to 70K and more for some complex products like the tablet PC and stuff like that.
And that's if you don't make mistakes, right?
Yeah, unfortunately, sometimes if you iterate too much, there would be a tooling repair costs and retooling costs, which might easily cost tens of thousands of dollars for the major change. So that's why I do encourage you to basically test everything before we step in the tool and iterate as early as you can. So
We actually,
please.
Alex, I'm sorry to interrupt. We actually had a quick question here. We'll keep the questions for the end of the webinar, but this one is on point and right on the subject. It's please tell us, Alex asks, please tell us about your most memorable and instructive failure from your previous experience in hardware development. So please share the worst one you had so far.
Oh, well, there's been a number of, because without failures, so basically it's very difficult to go. So probably the major the major learning curve would still have to happen with you for you to gain some knowledge. As for the major ones, I can remember several cases when the first the mass production lot was heavily damaged due to manufacturing partner carelessness. So, for example, when the say air duct on the mass production floor was broken, and the water and oil was running on the set of newly produced goods. But the good news are, so basically it was the manufacturer's responsibility, and they had to just produce all of the sets once again. So probably it was the major issue I've met so far. Smaller issues like the retooling, they normally do happen, but again, so it really depends on the maturity of design. So we try to implement what we call a DFM, so basically design for manufacturing aspects early on. So in order for us to avoid the retooling and changes on the later steps.
We've seen a lot of products fall through when they're on the assembly line, and they're, for example, they're not designed adequately. So they look like they could be assembled in a couple of different ways. So sometimes our engineers implement different tactics to make sure that when somebody's assembling it, there's just one way to assemble the device and they can't make a mistake at the factory line.
Yeah, thanks for this question. Really nice one. Yep, and then again, if we are talking about high-level production planning cycle, when we implement this kind of decision-making metrics, so it usually happens early on. So it usually happens during the research phase. So at this point of time, you should understand where and which component you purchase. There are always several choices available. So they are built by a partner. So, and basically you can make this kind of decision for each and every aspects, including the ID/MD design, including the hardware, including the firmware. So, and we'll speak about this later on. Next slide, please. Talking about this kind of build versus buy versus partner. So I guess the best way to understand this this framework would be to go through the simple project. So on this slide we have a plant watering sensor, plant watering solutions. You see them a lot, and they are perhaps one of the most simple IoT devices. So their purpose is to measure the soil moisture, and then to send some alerts if the flower or plant requiring watering. So, and normally when we are being asked, so whether we should develop the product in-house, we are normally trying to discourage our clients from reinventing the wheel. So when there are solutions available in the market and those solutions are mature enough, so unless you want to introduce some innovative approach or innovative feature, so you won't probably have to just make the product from scratch. And some of the parts you can reuse from the existing supplier. So talking about the plant watering solution, for the ID/MD design, especially if you want to launch this product for the B2C market, so you want to have a beautiful design. So in this, truly speaking, there's very few beautiful plant watering solutions. So that's something probably you should invest in order for it to be attractive for end customers. Talking about hardware, so you don't want to reinvent the wheel here. So probably you want to reuse a stable solution unless you want to add some specific additional measurements. And you probably can source the existing boards from multiple suppliers. They are tried and tested, so it reduces basically the development cycle, and it allows you just to make sure that you've picked the best partner, providing the best measurement accuracy. Same can be said about firmware. So basically, it's a pretty straightforward firmware usually. So you have several basic parameters which you can tune, including the measurements per minute, for example, and including the units, and of course the accuracy, the formula, how you get those values. But again, so normally those devices are pretty stable and they have a pretty stable firmware. As for the communication, again, you rely on the subset of protocols, of wireless protocols already available. So probably there's a number of choices here, ranging from Bluetooth and Wi-Fi up to some long-range, low-power protocols like LoRa. As for the cloud and dApps, and here where the things are getting interesting, so normally Chinese supplier, they have the turnkey solutions, including the cloud and apps for those kind of IoT devices. But normally those apps and cloud solutions are pretty buggy. When it comes to cloud solutions, there's a lot of issues related to data privacy. So normally you cannot trust the data storage practices and the treatment of the personal data. And given the number of legislation both in the United States and European Union, so probably the potential data privacy issues, well, it can result in hefty penalties. So that's something which you'd better take care by yourselves.
All right. So once again, it's all about decision making, right? You need to make the right decisions in order for your product launch to be like successful. And I can completely attest to like the apps and the cloud solutions from like turnkey solutions. I recently purchased a smart AC unit, and it's like a Chinese white labeled good. So it came with an app, and yes, it's a smart device, but I still to this day, I just use a remote because it's just way simpler. Half of the app is in Chinese, and it's not intuitive enough for me as a remote would be, let's say.
True that. Yep, and just to show the opposite example, here we have just the device type or product type which gains popularity. So it's the skin sensor patch with UV sensor, at the same time several sensors which are sensing the skin moisture and so on and so forth. So you'll see more and more devices like that on the market, but so far, very few partners, they're seasoned enough to produce these kind of devices in volumes and to produce them in a reliable way. So that's probably the case where you have to find the reliable partner who will take care of all the headaches related to the flexible boards, because they're still oftentimes immature, and especially when they are in constant contact with the fluids like the sweat and so on and so forth. So there's a lot of specifics involved. So talking about ID/MD design, so of course, in order to make this kind of device attractive, you would have to invest, but still you have to talk to the seasoned manufacturing partner who've launched this kind of products before, in order to make sure your design fits current technological stack. Because oftentimes you have a very beautiful picture, which as soon as you go to manufacturing partner, it starts to dissolve and becomes something ugly at the very end. So that's not what you want to have as a result. So for the hardware, you would definitely rely on a seasoned partner. Otherwise, you would have to go into basically a long R&D cycle, and this cycle might take several years for your internal team to fully master say the flexible circuits and some biosensors. So for the firmware, you can control it by yourself. Same can be said about communication, cloud, and app. So, talking about the multiple reasons why the project might fail, probably some of you can remember the Jawbone app, so which was probably one of the first fitness trackers targeted on consumer markets. So, and basically it was a very nicely designed product, but it was perhaps a little bit ahead of time. So it had a semi-flexible circuitry, which was the major issue for its instability and major issue for its failure. So the statistics for the first generation of this product was that almost 50 to 60% units failed after some time because of this kind of tricky semi-flex board design. And then the manufacturer had nothing to do but issue the replacement without any reverse logistics. So basically, you had to sign the statement that you will not resell your device on wherever. So, and then they shipped a new device for you. So next slide, please. As for the summary, so those are very high-level pieces of advice. So first of all, an early and comprehensive study of the project can significantly reduce risks and a number of mistakes on the later stages. Ideally, your team should have the product owners for each of the subsystems, so be it a hardware, software, industrial design, and mechanical design, and one guy who sits on top of those owners and controls all of the aspects. For someone should observe the bigger pictures. Alternatively, you can outsource this to one of the design houses, including ours. So, and IoT and smart hardware devices, basically they are all about the partnership. So we strongly encourage you not to reinvent the wheel if there are some doubts about basically your team knowledge and experience. And once again, we strongly encourage you to learn more about the existing solutions in terms of functionality and the costs. So it applies for basically all of the items in this stack, including the hardware, firmware, software, and so on and so forth. Well, we strongly encourage you to elaborate a working scenario with the minimum dependence of your future device on the networks, third-party services, and cloud. So in the worst case, your device still should be able to work and to perform the main function. So even in case if your, say, cloud provider goes down, so the users still should be able to use device for what it was intended. And well, the last one is the part of this one. So basically, device can always fail. So there can be multiple of issues with your partners. So, and the important part of your device should still remain functional. Nicola, thanks a lot. So I'll leave it to you here.
Good, Alex. Thank you so much. I appreciate you sharing all the just a part of your knowledge. Let's say in this kind of brief and quick presentation. Obviously, we all know that hardware it's not an easy task, and there isn't like a full stack hardware developer. Yes, there might be a few in the world, but it's a very rare occasion. So what happens is you need to assemble a small and agile team that has experience and can tackle these issues that we mentioned. Now, on the screen, you'll see what team consists of, but the whole premises is that it's all based on partnership and knowing and understanding what people are doing in your industry, especially ours. So never hesitate to reach out, to ask, to try to gather as much information at those early stages to try to, let's say, avoid all of these mistakes that can easily pile up and multiply. We've seen like a times 186 cost increase in just like making those mistakes over and over again. So I'd say that there are people out there that that this is like their primary work and job. So let's say some enterprises that want to get into certain verticals, or it's just an individual that wants to develop a device. It's always good to turn to somebody that's experienced for advice. Now, I can safely say that with about 60 people that we have within our company, we can help you tackle these issues. And collectively, I'd say we have way more than 100 years of experience in total in developing and designing hardware. It's a classic one, and it can be a bit, let's say, cringy, but it's very true. And that's that the best time to plant a tree was 20 years ago, but the second best time is right now. So if don't be discouraged by the fixed costs and the internal costs and so on. Value is perceived differently, and if you have a truly unique project you want to bring out to the world, you best partner and gather as much information early on as possible. We'll slowly transition into, let's say, a quick Q&A section while we have Alex here to maybe answer a few technical questions or share his experience furthermore with you. I'd also like to add that all the participants of this webinar are welcome to send me an email if they need a free consultation call about their current or future projects, so we can discuss and see how far you guys are and how we can help and assist you. Right, and yeah, I also wanted to share a quick slide with you, just so you have some sort of a, let's say, an input on how much like some of these services will cost. So something like design research, which tackles those very early stages after ideation, is pretty much starts from $5,000 USD. Then design for manufacturing is about 15,000, and we've done this in the past for even enterprises that are struggling to optimize their manufacturing, like mass manufacturing. And then we have industrial design that can start from about 10,000, but can easily move to, let's say, 30 and 40 and even more on, depending on the actual project. And of course, for those of you who don't know yet, we have 3 offices. One is in Belgrade, then we have a San Francisco office, but we also have a Shenzhen office. So because we manufacture through our network of ODMs and OEMs, we have our feet and eyes on the ground, and more than 11 years now of, let's say, nurturing those relationships with ODMs. So if anybody needs any manufacturing support, that's something that we can also help you with. And the range is on the screen there. We'll have more upcoming webinars, just to keep in mind. So on the 23rd, we'll do a co-joint webinar on product success, which is taking validated concepts to serial production. And this will be a very fun and interesting way to compare how like pre-launch validation with your users can help you have a successful product, and then how to transition from those concepts and validated ideas into mass production. And yeah, you'll see some others on the screen that we'll explore later on, and as well as my email address. Okay, so Alex, I will just keep this slide here, and I will read you a few questions that we have from our wonderful attendees. So an anonymous attendee says, one simple piece of advice from the expert before going into hardware development, please.
Nice one. So one piece of advice. So again, probably I will reiterate what I said earlier. So please really encourage you to perform the study and analysis first. So be it a competitor analysis, be it a cost analysis, be it a product market fit analysis. So, and probably I encourage to go for this kind of proof of concept as early as it's possible, and validate it as much as you can. So be it focus groups, friendly user tests, and so on and so forth. So because basically this limitless number of improvements you can introduce on the early phases, so which later on would cost an arm and a leg.
So early on. And we have another one from Jose. What is the best way to reach a good quality of devices / parts if your manufacturing is far away in terms of like a development office? So probably thinking about, if I'm correct, Jose, like outsourcing it to somewhere like China or Taiwan or India, for example.
So basically, yeah, what you want to do is you want to control the procedures of the, first of all, the outgoing quality control on the key suppliers, so for the major parts, and then the incoming quality control on the assembly partner, and then outgoing quality control and QC procedures on the place of assembly of your device. So basically, it is possible, again, by outsourcing this. And I would strongly encourage you to say not to hire the, what they say, the quality control or audit companies. So because they are normally being focused on checking the final results. This one should be prepared early on. And basically, you need to modify and you need to update the QA and QC procedures of your manufacturing partners if you want to succeed in checking the quality. And also, there's a number of modern approach of checking the quality and test results for all of the units. So some of them, they involve what we call a test jigs. So we have internal development, so and those jigs are able to test our boards or the boards of our devices in real time, and then upload all the test results into the cloud. So basically, we see the amount of failures and what those failures are early on, and we can easily add the visual inspection using some industrial cameras in there, which would also allow us to take snapshots from different angles, so for us to be able to have the full pictures. But again, so as Nicola has already mentioned, we have our team in Shenzhen, China, so they are able to control all of the manufacturing aspects. So
Right. Somebody asked, please, can ESP32 boards be used for products in production?
Well, this interesting perception of expressive when it comes to manufacturing. So they were perceived as some boards for the hobbyists early on, because basically it was one of the cheapest solutions out there. But since that time, they've evolved a great deal. So we can attest that their latest products are, well, very competitive in terms of stability and in terms of pricing, even for those mass production. So they are no longer just a more hobby solution. So, and we've launched products based on the ESP32 several times. So the only caveat, like with all the Chinese Wi-Fi solution manufacturers, would be the patches. So normally there are some vulnerabilities, well, based on the certain Wi-Fi stack, and you might want to make sure that you are using one of the latest of revisions of the ESP32 series, because the support timing is limited. So, and you probably want to use the latest and greatest model of the ESP32.
Here's an interesting one, and it's worded perfectly. Is it even possible to do it on your own, meaning hardware development?
Well, it's possible, and I've seen a number of examples where the small team is pulling out basically a new hardware product. But again, it all depends on the complexity of the product. So something more or less simple, well, even a very seasoned team of maybe 2 or 3 people can pull in. So, but when it comes to some more complex devices, so it all depends on the number of R&D resources that you have. So, and that's why I again encourage you to fairly understand your abilities and your capabilities. So, and the earlier you do that, the better. So, and again, it's all about being true to oneself. So, but again, so there are some good examples where a relatively small team have pulled out the very nicely made projects with some simple and straightforward purpose.
Most complex isn't always the best option. Sometimes there are gaps in the industry where you can find like your product fit, and it could be a very simple solution. Alex, we'll do 2 more if you don't mind, and we'll be wrapping this up. Maria asks, who should be on the development? Who on the development team is an essential person, like an essential item?
Well, again, it really depends. So normally, if we are talking about B2C products, so the essential role would be well, the electronic engineer, which sometimes might be a universal soldier responsible both by the board layout and by the firmware development. So again, we should verify whether our members are seasoned enough or not for that. Then there would be industrial designer. If we want to design the industrial design in-house. And then there should be a mechanical designer. Normally, you don't want to skip this role, although it might seem pretty easy task just to fit the board in the housing. But there are a number of aspects, especially in more complex projects, which can totally ruin your future product and
Right.
the assembly of it. And then probably you would have to have well, the guy responsible for the mobile and backend development. So sometimes, again, there are some universal soldiers which can easily be responsible for the front end, back end, and then mobile apps. But again, it's not a very frequent. It's not a very frequent case. So you have to hunt for those guys. And then it's good to have a project manager who will manage all of this mess.
Good. And Alex, this is the last one. It's Jose again that's thanking you for the previous answer. And he says, well, asks how to count how much devices should be tested and made quality control in the first mass production batch of devices, for example, around 3,000 to 5,000 items.
Okay.
So how many devices?
Yeah, this what they call an AQL lists. So by AQL, they mean the acceptable quality level. And it's pretty something tried and tested for tens of years, if not more. So there are a hefty number of tables and calculators which would allow you to calculate this kind of the percentage of devices you want to put through tests. So, and I encourage you just to search for the AQL calculators. Normally, they do come with a very detailed description. So, but we can just, if there's an interest, we can speak about this, the production side of it later on in a separate webinar.
Alex, once again, thank you for taking the time. I know that you guys are working around the clock on that latest wearable project. So thank you for setting the time aside to help us with this. Also, I would like to say a big thanks to all the attendees and everybody who asked questions and participated. We hope that you learned, first of all, but that you also had fun. In our eyes and minds, hardware is one of the best industries to be in, and there's no better satisfaction than creating an amazing product that users want to interact with on a daily basis, that inspires them to create something on their own later on. So once again, my email address is on the screen. Feel free to reach out for the free consultation, and make sure you follow us on LinkedIn. We post very useful content there for everybody from individual to like enterprise level. And yeah, just follow us and see what we come up with next.
Well, thanks a lot to everyone. And once again, thanks for having me here.
Thank you, Alex. Guys, thank you all. See you. We'll see you next time.